Within the course Design of Information Systems, we are currently discussing OCL data types and their operations. We have seen already a class diagram with the four basic UML-OCL data types: real, integer, string, Boolean, together with a more general type OCL-Any. And within this class diagram we see the operations that are available on the respective types. And we have seen the general definition of a term. A term is either a constant or a term is constructed by the application of an operation to already existing terms. In order to work with terms for the basic OCL data types, some particular constructions are very helpful. So some constructions from OCL, some features from OCL that are generally available are heavily useful in connection with using terms for data types. And these features, these general features from OCL that are needed are let terms, are conditionals, are sets and check for set memberships, and checks for supersets and the handling of subsets. So let us first go through these features in a general way as we see it here, and then let us look at more concrete examples how these features are used in particular situations. So variable names may be used in terms in connection with the keyword let. You can define a variable in an OCL term, and the variable will be sort of assigned, equated with a term, a general term, and then this variable can be used in a second term here. So this term, optionally with variable, is a term where this variable can be used, and in particular if this term uses this variable here twice, then the term will be shorter. This term here on the right hand side will be shorter than when you explicitly repeat some expression. We will see an example. Conditionals may be used in terms. So in OCL there is an if, then, else, and if. If, Boolean term, then term, else term, and if. In OCL there is no if-then. So there is an if-then, else, and if in OCL, but there is no if-then and if, as usual in control structures of programming languages. The reason is a value has to be calculated in an OCL term, and this is independent. The value has to be stated independent of whether the bool term is true or whether it is false. So this term has to deliver a value in both cases. It has to deliver a value for the then case and for the else case. The third general feature, we see it over here. Sets and set memberships. When you have a larger disjunction here, as you see it, x equals E1 or x equals E2 or x equals E3, this can be equivalently written as you spontaneously build a set, namely the set consisting of the expressions E1, E2, E3, and you ask whether the set E1, E2, E3 includes the x. And the expression on the left-hand side and the expression on the right-hand side are equivalent. The fourth and last feature here that I want to discuss are tests for supersets and for subsets. We have seen the includes all already. The includes all is sort of an abbreviation or equivalent statement for if you have a set S and you want to assure that the set S includes an element E1 and the set S includes an element E2, then you can use the includes all in the sense that you can write S includes all set E1 and E2. And I already said a good way of reading and thinking of expressions with includes all, a good way of reading the expression S includes all S2 is to read it as S1 is a superset of S2 with equality, making this term also true. So, to formulate it in a general way, we have S1 includes all S2. We have used a set here as a parameter for includes all. Includes all always has a set as a parameter. And S includes all S2 is equivalent to, you can think of it as S1 is superset of S2, or equivalently in mathematical notation, S1 superset of or equal to S2, and on the other hand you can exchange S1 and S2, and then you can read this as S2 is a subset of S1, and this can be written also in mathematical notation. S2 is a subset of or equal to S1.